welcome as we go over the example 1 part of the Unit 1 Day 4 notes for AG2. Here we have finding the coordinates of the midpoints. So we're going to find the coordinates of the midpoint of line segment, make sure you say it right, CD, with endpoints of C, where it's -2, -1, and then the point D is 4, 2. What I've given to you off to the side here is also a coordinate grid that we could then lay out. So let's go ahead and set it up visually first on the coordinate grid. Our goal is to be able to do this what's called algebraically. So there's two different kinds of ways of being able to do this, algebraically and geometrically. Geometrically is using space, so using the coordinate grid, and then moving then to algebraically where we don't need to use that as, don't need to use the grid to help guide us, where we can kind of see it algebraically. Both are correct, both are viable ways to work through this problem. So first I'm going to go ahead and plot C of -2, -1. I'm going to go ahead and write underneath here x sub 1 and y sub 1. So I'm doing that sub 1 because there's 2 points there. So because there's 2, I'm going to put x sub 1 underneath the -2 and y sub 1 underneath, that's my x value and my y value. And then that would make my D my x sub 2. 4 is x sub 2, and then this 2 here is y sub 2. And that helps me just kind of keep everything straight. Over here on the grid, I'm going to go ahead and plot point C. So to get there, I go to the left 2 from the origin, that's -2, and then -1 is down 1. So that puts a point here. So this is point C. And then I'm going to go ahead and mark D as well. D is 4, 2, so I'm going to go to the right 4 from the origin. 1, 2, 3, 4, and then up 2, 1, 2. So that gives me my point. Now that I have these two, I'm going to go ahead and put the C, capital C, off to the side here, capital D off to the side. I'm going to have to actually write x sub 1, y sub 1, or the ordered pair -2, -1 next to it. So that'll help me through that. I'm going to go ahead and write down, copied out the formula just so that I have it off to the side. That will help me as I go through and solve this. So I know that I'm, going to be taking x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. Knowing these, I'm going to plug in or substitute the values for these other ones. X sub 1 is -2, so this is -2 plus, and then x sub 2 is 4, and that is all divided by 2, comma. And then the next value that I have, y sub 1, is -1, so -1 plus, and then y sub 2 is 2, and that is divided by 2. Now I can simplify this. Talked about this a little bit in my last video, but we have what's called ninja parentheses, the hidden parentheses, you can't see them. So the ninja parentheses are around that -2 and plus 4, so we need to do that first. You can grab your calculator if you need to. -2 plus 4, if I check that out, -2 plus 4 is in fact +2. So this is going to be 2 divided by 2. And then -1 plus 2, if I add those two together, I get a +1. And that gives me with 1 divided by 2. I did say 1 divided by 2, that's also 1/2. Both of those are equivalent representations. They mean the same thing. I can go ahead and simplify. When you have an opportunity to simplify, please do so. So 2 divided by 2 is in fact 1. And then 1/2 is 1/2. So that would be the midpoint for this particular segment, line segment CD. So the midpoint of CD is this. So the midpoint of segment CD is 1, 1/2. Now if I put this on this grid here, so if I go over 1 and then up 1/2, what you should notice is that if you connect these with a straight edge, so if I go from C to D, the distance between C to that midpoint and D to that midpoint should be the same. And in fact it is. And you can kind of see it visually if you graphed, plotted those points correctly, you should be able to see it. Example 1, so this is just like the example that we just did. This is the same idea. Find the coordinates of midpoint segment EF with endpoints E, -2, 3. So I'm going to call this my x sub 1 and y sub 1. And then F So I'm going to be consistent, use the same colors here, so we have the same color scheme. We can jump back to orange. In case you didn't know, this is actually orange. X sub 1, y sub 1. And then x sub 2, y sub 2 for my other coordinate there, f. So I'm going to go ahead and plot these on my grid. So if I plot these on my grid, -2, 3, -2, 1, 2, 3. It means I go left 2 and then up 3. So there's my coordinate point E. And then f, 1, 2, 3, 4, 5 to the right from the origin, and then down 3. 1, 2, 3. So there we go for that. Perfect. All right. That's f. So now I'm trying to find the midpoint. So again, copying down my midpoint formula from the other side. X sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. So when I go through and solve this, if I plug in my values or my points, I'm going to go ahead and do that in green. So if I plug that in, I'm going to have, let's see, x sub 1 is -2, x sub 2 is 5, divided by 2, y sub 1 is 3, plus -3, divided by 2. Now I simplify, again, ninja parentheses, so I'm going to do, what's in my numerator, the operation of my numerator is first. -2 plus 5 is 3. 3 halves. And then 3 plus -3 is 0. 0 over 2. Again, I can simplify the 0 over 2, 0 divided by 2. 0 divided by any non-zero number is 0. So my midpoint is going to be 3 halves and then 0. You can leave it as 3 halves. You could also put 1.5. They mean the same thing, so understand that those are equivalent representations. So that would be here on my coordinate grid, and if I connect it using a straight edge, you can see that that is in fact the midpoint and equidistant from both. Equidistant means the same distance. Example 2. Using the midpoint formula, this is now going kind of the opposite direction, where I give you the midpoint, and now what we're going to do is we're going to try and find one of the endpoints. So the midpoint of line segment JK is M, one endpoint is J, find the coordinate of endpoint K. So let's think about what we know here. We know the midpoint. We know that the midpoint is 2, 1. So the midpoint here, M, is 2, 1. We know one of the other endpoints is 1, 4 here. And this is J. So similarly to what we did from up above, this is the midpoint for that one. We actually are trying to find, in this case, my other orange point. We're trying to find where the other orange point is. So visually, you can see this, that we are going 1, 2, 3 down, 1 to the right. So I'm going to guess, this is a guess, I don't have the proof yet, that we're going to go down 1, 2, 3, and then 1 to the right. So I think that this is where the other endpoint is. I'm not 100% sure. We're going to find out here in a second. If I list these out kind of in order, so I start with my endpoint. So I start with my endpoint J. So my endpoint J is 1, 4. And then I'm going to list out my midpoint, M. That's 2, 1. And now I'm trying to find endpoint K. So to get from 1 to 2 mathematically, I need to add 1 value. So if I think about to get from here to here, I need to add 1 value. So similarly, to get to the next, I need to add 1 value. So if I think of this one, this is going to be 3. To get from 4 to 1 mathematically, I need to subtract 3 minus 3. So then to get from 1 to the next value, I also need to subtract 3. So that would be 3, -2. So my other point there, my endpoint K, is 3, -2. Now if I look at what I drew in over here, that is exactly what I predicted it to be, was actually 3, -2. For this next one, the midpoint of VW is M, and then I give you one endpoint is W. You always want to start with the endpoint that it gives. So I'm going to start with endpoint W. So if I start with endpoint W here, that's 4, 4. The midpoint, M, for this one, is -1, -2. And then the other endpoint that I need to find is V, endpoint V. So to get from 4 to -1, I need to subtract 5. And then to get from 4 to -2, I need to subtract 6. So now, to get from -1 to the next value, I also need to subtract 5. So if I do that, if I subtract 5 here, -1 minus 5 is -6. Then if I subtract 6 from -2, this is -8. This is actually off this grid if we go by a 1-to-1 scale. So I didn't draw it on purpose because it doesn't fit on this particular grid. So you'll find that maybe you can't approach a problem geometrically with the tools that you have. And this would be approaching it geometrically, making a diagram or a shape to follow. But we were able to do this kind of thought process-wise algebraically. So we were able to successfully get the endpoint. One thing that I want to note is you want to make sure that you kind of make your answers clear. You can do that one of two ways. You can highlight it, you can box it, you can star it, you can circle it, whatever you want to do to make sure that you know, oh, this is the answer that I need you to check. This is the answer that I'm trying to produce or I'm trying to find. It is okay to include work. In fact, all of your teachers, math teachers, we want to see your work. We're more concerned about the work than we are with the final answer. Hopefully this helps with using the midpoint formula, both to find the midpoint and then also to find an endpoint given the midpoint. See you in the next video.